Welcome, everyone. Today we are tackling one of the most critical topics in modern technology, the ethics of AI-generated content. We will dive deep into responsible usage, navigate the tricky waters of plagiarism concerns, and uncover why human-in-the-loop verification is your ultimate safety net. Let's get started. What does it mean to use AI responsibly? It goes far beyond knowing how to prompt. It is about developing ethical fluency. AI models are incredibly powerful pattern recognition engines, but they fundamentally lack moral intuition, lived experience, and cultural context. As professionals, our foundational baseline must involve transparency, accountability, and fairness. You shouldn't just ask, can the AI do this? But should the AI do this? This requires establishing clear boundaries, protecting user privacy, and ensuring that our AI usage aligns with human values rather than just maximizing narrow efficiency metrics. This flowchart illustrates the lifecycle of a responsible AI request. It starts with the user, but immediately hits an ethical fluency check node. If the intent is unsafe, it gets rejected or modified. If it's safe, it moves to AI processing. Crucially, before it becomes a final output, it must pass through a human validation node, ensuring the final deliverable is ethically sound. Let's address the elephant in the room: plagiarism and academic integrity. The golden rule of AI transparency is simple. Would you be comfortable if everyone knew exactly how you used AI for this task? If that makes you squirm, you need to reconsider your approach. AI should be a collaborator, not a ghostwriter. Whether you are a student or a CEO, you must define the difference between using AI to brainstorm, structure, or understand concepts versus using it to bypass actual learning or pass off machine-generated text as your original thought. Always follow institutional or corporate disclosure guidelines. Looking at this decision tree, we map out the boundaries of authenticity. When executing a task, if AI is used for ideation, it leads to acceptable use and human synthesis. But if it's a direct copy-paste, you enter plagiarism risk territory. The deciding factor then becomes disclosure. Transparent disclosure might be evaluated safely, but hiding it results in a direct ethical violation. Data privacy is a paramount ethical concern. When interacting with an LLM, you must practice privacy-first prompting. Never input personally identifiable information, proprietary business secrets, medical records, or confidential client data into unsecured models. Instead, use the anonymization approach. If you need to analyze a salary report, don't say, John Smith at Acme Corp earns $75,000. Say, an employee at a tech company earns a mid-market salary. By obfuscating sensitive data before it reaches the AI, you maintain the utility of the model while protecting your organization from catastrophic data leaks. This diagram shows the secure data flow. Raw confidential data must first pass through an anonymization filter on your local machine. This creates a sanitized prompt containing no sensitive PI, which is then safely sent to the LLM. Once the AI returns its output, you perform the final step, re-identifying the data locally so it makes sense for your internal business needs. Even the most advanced models can experience hallucinations generating confident, plausible, but factually incorrect information. This happens because LLMs predict text based on statistical patterns. They do not know facts in a human sense. When researching, you must apply the trust but verify principle. Always demand citations, ask Claude to explain its reasoning step by step, and cross-reference critical claims with authoritative external sources. Relying blindly on AI for medical, legal, or high-stakes financial data without rigorous verification is a massive ethical and professional risk. Here we visualize the verification workflow. Whenever you receive an AI-generated claim, ask yourself, is this high-stakes? If yes, you must manually cross-reference the original source material. If the source is verified, it is safe to use. If it fails verification, you must discard the output or regenerate it. Never skip the verification node for critical information. To combat hallucinations and maintain ethical standards, we rely heavily on the human-in-the-loop, or HITL architecture. This is the 80-20 rule in action. Use Claude for 80% of the preparation, heavy lifting, and data processing, but rigidly reserve the final 20% for human judgment. HTL means you are the orchestrator. You set the strategy, review the logic, and make the final call. The AI cannot bear ethical responsibility, express genuine empathy, or understand deep cultural context. By designing workflows that mandate human approval gates, you ensure accountability and elevate yourself to a strategic director rather than just a task executor. This sequence diagram maps the perfect HTL interaction. The user gives the AI a task. The AI does not finalize it. Instead, it sends a proposed action or draft to a human gate. The human reviews, evaluates, and verifies the facts. Only after the human approves the revision does the AI deliver the final validated output back to the user. How do we implement HTL practically? We can use the 3-layer quality system. Layer 1 is Claude's self-check. Ask the AI to review its own draft against your specific guidelines to catch obvious misses. Layer 2 is human judgment. You, the domain expert, review the output specifically looking for logical inconsistencies, tone mismatches, or factual errors. Layer 3 is the final polish. Once the facts are verified by you, you hand it back to Claude to smooth out the grammar or formatting. This systematic pipeline catches errors early and ensures that the final deliverable is both high quality and ethically sound. Notice the sandwich effect in this flowchart. The process begins and ends with the AI generating the initial draft and doing the final polish. However, right in the center, acting as the critical bridge, is the human expert review. This guarantees that the core substance of the work relies entirely on human accountability. Let's examine a real-world use case, building an automated customer support triage system. If we let the AI automatically reply to sensitive medical or financial complaints, the risk of harm is immense. Instead, we use an API code snippet to enforce a harmlessness screen. We pass the incoming message to a lightweight model with a prompt like, classify if this message requires human empathy or legal review. Respond safe or escalate. If the AI detects high risk, it escalates the ticket to a human manager immediately. The AI only auto-replies to basic, safe FAQs. This perfectly blends operational efficiency with strict ethical risk management. This architecture diagram maps out our use case. Every incoming message hits the harmlessness screen API first. This is our automated ethical filter. If the intent is flagged as high risk, it routes instantly to a human agent for empathetic resolution. If it's a safe, low-risk query, it takes the right path to AI auto-response generation. To conclude, responsible AI usage is about treating Claude as a capability amplifier, not a human replacement. We must maintain our critical thinking, protect sensitive data through anonymization, disclose AI assistance transparently, and always enforce human-in-the-loop verification for high-stakes tasks. By mastering ethical fluency, you not only protect your organization from compliance risks, but also future-proof your career in the age of AI. Thank you for joining me today. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Our final diagram distills ethical AI mastery into 4 unshakable pillars. On the left, transparency and disclosure. Next, privacy and anonymization to protect data. Then, human-in-the-loop and verification to prevent hallucinations. And finally, human accountability, reminding us that while AI does the processing, we take responsibility for the outcome.